A popular VPN client pushed its newest version to GitHub on Tuesday. Within minutes, developers worldwide started cloning the repo, eager to test the promised speed boost. Then, at 2:17 Universal Time Coordinated, the open-source scanner GitGuard flagged a single line of code that opened a socket to an unknown IP address. The alert read, "Potential remote execution backdoor detected." The repository owner was stunned. No one had announced a feature like that. Within 4 hours, the scanner traced the socket to a hard-coded address in a rarely used networking module. By the next morning, the commit had been removed, but the damage was already public. A single stray line, hidden among thousands of lines, had exposed users to a malicious gateway. This is how an automated watchdog caught a VPN backdoor in just 24 hours. Meet Secret Scanning, GitHub's built-in security engine. It runs constantly on every push. The system checks code patterns against known credential formats and API keys, private tokens. Think of it like a 24/7 security guard reading every line. When someone commits a secret, password, token, private key, it flags immediately. But this time, it found something darker. Obfuscated C code hiding malicious network behavior. The scanner doesn't just catch exposed credentials. It's trained on years of actual breach patterns and discoveries. Major platforms like AWS, Google Cloud, Stripe contribute detection rules. This collaborative rule set is why developers trust it. The backdoor code was subtle, months hidden inside a legitimate update. Yet the scanner's pattern recognition caught the telltale signs. In minutes. Not because it knew this specific backdoor, but because it understood the linguistic fingerprints of deception. The malicious commit added a single file named VPN_backdoor, the C. Inside, the author defined a function called init_backdoor that runs on library load. It opens a raw socket, listens on UDP port 4567, and forwards any packet to 10.0.0.5:1194, effectively tunneling traffic through the VPN server without authentication. The code uses a pragma directive to hide the symbol from the export table, so static analysis tools see no obvious entry point. A comment in the diff reads //temp fix, a classic misdirection that reviewers skim over. The backdoor is wrapped in a hashtag ifdef debug block, meaning it only compiles in production builds where debug is defined by default in the make file. Because the repository's CI pipeline skips linting for files under util/, the file never triggered a warning. Finally, the author altered the .gitignore to exclude the new file from the code coverage report, ensuring the test suite never touched it. When the commit landed, the scanner kicked off its static analysis pipeline. First, the file tree was hashed. Then each new or modified file passed through a series of YERA rules. Rule VPN Backdoor 001 flagged any hard-coded OpenVPN binary blob combined with a base 64 encoded payload. The rule matched line 42 of the added file, where the attacker had embedded U2 FSDGKX1+. Inside a C++ string literal. The engine recorded the match, generated a serif report, and sent a webhook to the security channel at 2:13 Universal Time Coordinated. Within seconds, the alert bot posted the finding, linking directly to the offending commit. The security team opened the link at 2:15, inspected the diff, and immediately reverted the commit. By 2:45, the malicious file was removed from the repository, and the CI pipeline blocked further pushes containing the same signature. The whole chain, from commit push to alert, took just 32 minutes. The VPN repo vanished from GitHub within hours, its maintainers issuing a public apology and a full rollback. Users who had installed the compromised client faced immediate credential revocation and forced password resets across thousands of accounts. The incident rippled through the open-source supply chain. Several downstream projects that bundled the VPN library had to audit their own code bases, delaying releases by days. Security teams worldwide cited the case as proof that automated scanners can outpace human review, prompting many companies to add continuous secret detection hooks to their CI pipelines. Developers learned 3 hard lessons. Never store private keys in plain text. Always enforce branch protection and require signed commits. And treat every third-party dependency as a potential attack surface. The fastest mitigation was a coordinated patch, a new release signed with a hardware security module, and a transparent postmortem shared on the project's wiki. Now you see why every security team needs this scanner. It flagged a hidden VPN backdoor in under a day, saving thousands of users from data exposure. The tool runs on any CI pipeline, scans every commit, and alerts with precise code locations. You can install it from its open source repo, just clone, configure the webhook, and let it watch your repository 24/7. It integrates with Slack, Teams, and Jira, so the moment a risk appears, the whole response chain is triggered. Companies that adopted it reported a 78% reduction in critical findings over 3 months. If you care about protecting your code, give this scanner a try and contribute to its roadmap. Subscribe for more deep dive security stories, hit the bell, and drop a comment with the toughest bug you've faced. Together, we keep the open source world safe.